Cool, so thank you everybody for joining us. I know there's a ton of cool stuff to see at SIGGRAPH, so the fact that we have an almost full house is awesome. Thank you so much for spending the time to see what we're doing rather than what anybody else is doing. My name is Alex Jenyon. I'm the head of environments at MPC Film Vancouver, and this is John Vanderbeck. He used to be my internal developer. He's now part of the Genesis team, so he's working on the Genesis tools that you might have heard about in the last talk. And we finally want to show publicly something we've been quite proud of, we've been working on for a good few years. We've developed a real-time set dressing toolset inside of Unity called Diorama. And obviously showing it at somewhere like SIGGRAPH is pretty awesome. And SIGGRAPH is the perfect place because in visual effects, we don't often get the opportunity to thank the developers that make the tools that we use every day. Sometimes it's difficult to know who actually worked on the tool, and sometimes it's difficult to give credit. But in this case, it's pretty easy, because every single line of code of every tool that we're going to show was written by John. Now, a little bit of background. Some of this is repeated from previous talks that we've given. In particular, we spoke at SIGGRAPH last year, accelerating film environment creation using game development tools. And we've had a bit of time since to roll out some projects we weren't allowed to talk about at the time. But also, we've done quite a bit of work since then, and that's one of the things I want to tell you about. So a bit of background. In 2015, it was pretty clear that the environments department needed a new scatter tool. We had a ton of people using SP Paint, which is known internally as the RSI tool. It's pretty valuable. It's been around for a while, but it's also a bit limited, a bit difficult to use. We had a particle-based scatter tool that was written inside of Maya, but that was a bit limited and a bit difficult to use as well. So I gathered anyone in the department who was interested, and I put them in front of a whiteboard, and I got them to spec out what they thought the perfect environment tool would look like. Now, it would need to have some pretty basic functionality, things like random scale, random rotation, really basic stuff like that. But everybody wanted some more advanced functionality as well, things like layering, coloring, and clustering. Now, this wasn't DCC specific. We weren't thinking about which program we were actually going to build this tool in, and we certainly weren't thinking about game engines at all at the time. So our initial efforts focused on the node-based scripting engines. Now, I know this is a Unity talk, and I've just put up an Unreal slide. Please bear with me. But we wanted to find a node-based scripting engine that we could write the tool in. And Unreal was one, which is Blueprint, and Fabric Engine, which has sadly been deprecated, was another. And we ended up focusing on Unreal Engine. It took most of 2015 into 2016. But by Christmas 2015, we could import models from the MPC pipeline. We could import cameras with image planes from the MPC pipeline. We could do real-time set dressing and layout, and we could export the result as one of our internal layout packages, a model hierarchy package about to the pipeline. So we had Unreal Engine fully pipelined. We initially did a small test, but the first project that we used this in anger was Justice League. We had to create the third act, Scrindle 1 environment. We had about 8 people working on this environment at one time. And John wrote some spline scatter tools in Blueprint, which proved to be pretty valuable. But we did find that artists were sneakily using Unreal's built-in foliage paint. And this carried on with the forest monster sequence on Disney's Wrinkle in Time. And we were still using spline scatter, but even more use of the foliage paint was seen on the floor. And because we're artists, we started complaining about them, and we started hassling John to try to improve foliage paint. And that's actually quite hard to do. It's in a lot of different libraries, and you have to compile the entire editor every time you do an update. So it is a little bit difficult for one developer working on their own to edit foliage paint. So around this time, we switched over to Unity. So this isn't an engine wars type conversation. We had lots of reasons for doing it. Both of us still use both tools. But we wanted to align with the London team, who were just starting the work on the Genesis project inside of Unity. And we also wanted to make sure that one developer working in a department somewhat isolated and on their own could develop the big tool set we had in mind. So this gave us an opportunity to write an environment layout and scatter tool from scratch. The code name we used initially was Diorama, and it just stuck, so that's what we've gone with ever since. But designing it from the ground up means going back to some pretty basic principles.
So at the end of our talk last year, we briefly mentioned Diorama on a couple of slides, and now we have the opportunity to actually take a look at it. So world building, when you bake it all down, world building is really just about generating points. So you have an object in the world at a specific position, rotation, and scale. In Unity, that's your transform. So it's just about making those points when it comes down to it. There's several ways you could do that. There are random generation algorithms. You can use particle systems. You can use procedural growth-based systems. You can use painting-based systems or templates. In our case, we decided to go with something that gives us a little bit. We need proceduralism, but we also wanted artist control. We needed to get the best of both worlds, basically. So we decided to start with a static template-based system and use a layered approach to build on top of that to give us proceduralism and artist control. So I'm going to break this down a bit. I'm going to throw a bunch of terms at you. Hopefully it makes sense. It all starts with a diorama template. A template is a collection of sockets inside of a volume of space. Each one of those sockets has a position, rotation, and scale, but it's built by an artist ahead of time. It's in this form, it's static. It doesn't change. It doesn't do anything. It basically just looks like that in the editor. But we add rules to those sockets. So each one of those sockets gets procedural rules applied to them. And those procedural rules now start to give us a level of variation from the same template being spawned multiple times in the world. We're going to get different results from those rules. The next layer of proceduralism or variation comes from how those templates get into the world. We do this with what's called strokes, which paint the diorama instances onto, or the diorama templates into the world. Where you see in this image here, every one of those little locators is what we call a master point, and that is at that point where a diorama template will be spawned as an instance in the world. When you combine those together, you basically get multiple instances of dioramas with all various seeds running various rules to get something like that. So while we start with a completely static design in the form of a template, as we flow through the system, we layer on additional levels, which gives us that procedural aspect. It's completely deterministic, except for one caveat, which we'll talk about later, which means you can rerun the rules over and over again and get the exact same result each time, which is good. But you also, at any point as an artist, can step in and take control without losing the procedural nature, which is really great. And so if none of that made any sense to you, just think of it this way. It's a 3D Photoshop brush. Okay, so we're going to attempt to do one of two live demos. We've already a step ahead of our last talk because the machine turned on. Okay, so we're going to show you a tutorial level that we set up for internal instruction, and we're going to start with a very simple static template that never changes, and we're going to build up from there. So again, static template, this is literally just a bunch of sockets with a rule that says put a sunflower on there, and every time Alex draws it, it's going to be exactly the same no matter what. So we need to start adding some variation to that.
If I can get your hotkey to transfer to the next one.
Are you pressing the right hotkey?
Yeah.
It's in the menu too.
That is very true.
Nothing ever goes right in a live demo.
No. We are using a different keyboard than we have used in the past.
It's under Window.
Manager, Control, Alt, and N.
There you go. Okay, so let's add some variation in there. So this is going to be the same three objects, in this case rocks. They're always the same, they're always in the same position, but they're going to be randomly rotated in X, Y, and Z, so you start getting variation in there. And just like random rotation, we can do random offset. So positionally, we're going to what's called a jitter position rule. Each one of these boards is going to have some variation to it. It's the same diorama spawned multiple times, but each one's going to produce a slightly different result. Now, one thing we realized early on, though, and unlike the image I showed you earlier, there's nothing that says that a diorama needs to be a flat image. It's a volume of space. Those sockets can be anywhere. In this case, we decided, well, hey, let's make a Stanford bunny out of a bunch of sockets. And as you can see here, too, Alex, even though he'd used a procedural system to build it, he can go in and modify it after the fact. Random visibility. So what we've shown you so far is a bunch of sockets that are always there. But that doesn't always make sense. In this case, we have a grid of sockets, just like basically a square grid of sockets. But the ones in the back have a rule that says they're more likely to appear than the ones in the front. So again, you're going to get some variation each time you do this. Multiple prefabs. So there's no reason that, what we do is, what you've been seeing up to now is a select prefab rule which picks one thing. But that select prefab rule says, give me a weighted list of things you want me to choose from. And in this case, we've got rocks and brushes, shrubbery and bushes and whatnot. And if you paint a lot of this down, you see you get stuff very quickly, but not very naturally, right? It's too dense. So let's add another rule. Hide if overlapping basically says when I spawn myself, I want to look to see if anything else is there and maybe I don't need to spawn. So you get density without interpenetration, basically. So next is our align to surface. Now, this is a little bit more complex, so bear with me. I mentioned before we have a stroke which puts down the dioramas. And that stroke is going to give information to the master point, like random rotation, random scale. And in this case, it's saying that stroke is going to align to the surface of what I painted on and pass that information to the diorama. So moss, for example, is very easy. But you also can turn that off if you want, or even set a level. So if you just want to paste, say, mushrooms on the side of the rock, you can do that as well. It's basically a 0 to 1 value depending on how much you want it to align. But now let's start introducing something a bit more advanced. A ray cast rule basically says for every socket that has this rule, it's going to cast a ray in a certain direction, and then wherever it hits is where the socket's actually going to end up. One really powerful feature of this, though, is let's say you paint a bunch of stuff on the ground's never going to change, right? Yeah, no. The ground's going to change. So all we have to do is rerun those same rules on the new ground, and it'll all adapt. Boom. Simple, simple. So let's make this a little bit more complicated. I said before that the brush was passing information about the normal of the surface it hit. But the problem with that is if you have a flat, really large diorama, everything is going to be at the same plane. It doesn't make any sense. So in this case, the raycast rule can take each individual socket and align it to what it collides with. And lastly, this is a little bit of a happy accident. A diorama can impact or collide with another diorama over and over again, so you could easily just stack up rocks, for example. This was done by mistake and really realized, hey, it's actually a pretty cool tool. So we've been showing you meshes being spawned by diorama, but really diorama takes any prefab. It's called the select prefab rule, and anything in Unity that's a prefab you can spawn, including lights, for example. So this is a Christmas tree, for example. And you know what? A diorama is a prefab, so let's put a diorama inside of a diorama inside of a diorama. In this case, we have a diorama that creates a rock with moss on it, and then that diorama is put into another diorama that has multiple sockets, so you get a bunch in one go. And so a little bit more advanced here. We now have the ability for sockets to do things that are contextually aware of other sockets in the template. In this case, the roots are always going to find the tree stump, and they're going to look or align their rotation so that they're facing that tree stump. So no matter where the tree stump is, the roots are going to be looking more naturally towards the tree stump. And in a very similar vein, we have a rule called clustering, or in this case, it's actually called move towards. It does the same thing. It has a target object and moves a percentage of its value towards that object. This is actually kind of a subtle rule, but each individual small piece of grass is moving roughly 50 to 100% randomly closer. Now, this rule is not so subtle. Sometimes the easiest way to scatter stuff is to just scatter it. You can do more than that. Surprisingly, Unity hasn't died doing this yet. And artists can simply flip a switch, physics on, physics off. It's real simple. So the next advanced thing we want to talk about is diorama layers. So we have a sort of a Photoshop-based layer system in diorama, and this gives us a couple of great features. One of those features is, let's say you're painting stuff along the side of a road, but that road in the future could move. So if you attach your stuff in a painting layer to the road, if the road moves, then everything else goes with it. That's pretty simple. You can do that in Unity on your own, but this just makes it easier for an artist to not have to dig into Unity's hierarchy to do that. But one additional feature it has is the ability to cull layers. So let's say you have that road going through a forest, and you don't want trees where the road is, but you don't want to worry about that. The road can call out the trees where it is, and the really powerful thing is it's non-destructive. So if you move the road later on, the trees that were culled will come back, and the new trees that should be culled will be culled. So that worked out pretty well. So the combination of painted strokes, static templates, and procedural rules allows us to create a wide range of different environments. As a general rule, we found architectural and hard surface environments tend to be more template-based, while organic scenes tend to rely more on a random procedural component. Artists who just want to start painting have a really easy-to-use tool. They just select a pre-made diorama for them, maybe make some tweaks, and just start painting. More technical-minded artists or anyone who wants to get more into the system can dig down, build their own templates, modify the existing ones. It's really quite simple. But why Unity? It's a fair question. We could have done this in Maya, we could have done this in Houdini, we could have done this in Clarice, we could have done this in lots of things, right? So why do we choose Unity? Well, we've mentioned a couple of reasons earlier, alignment with the rest of the company, but there's other reasons. One of the things that I really feel strongly about is a game engine has a level editor. It's literally designed for building worlds. Why not use it to that advantage? Another thing I love about Unity is it is a really friendly development environment. You're not rebuilding, literally building the editor each time. You're just making little scripts that add on, drop them in the project, recompile them, no problem. Makes it very easy to extend. And you also have less writing tools from scratch. We showed you a raycast rule, for example. If you did that in Maya, you would literally have to write a raycast routine. Well, in Unity, you just call physics.raycast. This tool is there already for you. And even if all these tools existed, one of the next thing that's really important is we have a high-quality real-time renderer, and that is, you'll see a little bit later on, is key because it allows not only rapid layout, but also rapid iteration. We can see the results of what we're painting in the scene immediately and make decisions. Not quickly, but immediately. So just a real quick breakdown on how this all works in Unity. There's no black magic going on here. It's all standard game objects and standard components, model behaviors. All the templates are stored as prefabs in the project. All the diorama rules are serialized objects, which are stored as assets in the project. We actually keep them together, so it's easy to export a diorama. And lots and lots and lots of custom inspectors. So, because once wasn't enough, we're going to try another live demo here. And we do want to give a special shout out here to Nature Manufacturer on the asset store, who really helped us bootstrap this by providing a bunch of assets for our use, as well as, I think, the only water I've seen that actually works in HDRP, which is great. So what we're going to do here is actually set dress and environment live, right in front of you. So Alex is going to start.
Cool. So being from Vancouver, we wanted to do something from the Pacific Northwest. And there's a really cool environment over on the Sunshine Coast where a bunch of pine trees have been overtaken by a swamp. So I grabbed the digital elevation model for that particular area. And we've started off with a basic layout. There's a couple of Nature Manufacturer assets for the rock formations and the background terrain. But I'm going to spend somewhere between 4 and 5 minutes, and we're going to dress up the entire scene to be a swamp environment. So first thing I think we want some rock clusters. So we've got a nested diorama. It's pretty similar to the one you saw. There's a large rock, there's a cluster rule where the small rocks are more likely to be around it. There's a physical scatter rule for some of the pebbles. And then there's moss that raycast down onto the lot. So I think I want to put a bunch of these around. Maybe that's a bit too close. So you notice that one of the things I quite like doing, John does it a bit differently, but I tend to put down something, see if I like it, and then very rapidly undo it. So I get the art direction of just trying to see what the happy accidents are going to be, and then like keeping them if I like what's there.
Basically, every time you paint down, they get assigned a new random seed. So if you undo it and paint again, you get a different random seed.
Yeah, but like we said, we thought we were going to be able to do this quite slowly, but Unity's actually being quite good. We haven't seen any significant slowdown yet, so I'm just going to put in a ton of these, just fill it up with some rocks. But it's a swamp. We're going to need physical scatter large. So let's drop in some stumps. Maybe a few more. John always says I overuse these, so I'm going to be trying to be very careful. And yay,
when you can throw things around physically, people tend to just throw a lot of things around physically.
It's rather good fun. So yeah, when we give these to artists, they tend to just go to town, and there's physical scatter absolutely everywhere. Now I'm going to put down just in the foreground a bit of cover, because it's looking a bit plain. We need a nice blend with the water. So I've got some dry ground cover that I'm going to paint in. Now, one of the things you'll spot is that it's raycasting onto the objects that I already have in my scene, and that's looking a little bit ugly. We don't want to have raycast onto the rocks we already have. But one of the things that John added to the layer system is a bypass. So I've just painted in a whole lot of rock scatter and large stumps, and actually I'm going to bypass that because I want to raycast onto the large rock formations, but I don't want to be on top of the stumps. So just undo that last one and paint a little bit more in. There we go. So it's not going to raycast down onto the stuff I just put in because we've bypassed that particular layer. I do also want to put in some green ground cover because it's a swamp. That's looking a little bit dead. So we have some green ground cover. There we go. That's kind of nice. Put a bit on here as well. So in the background, I'm going to do some mid-level plants. Just fill this in. I'm going to keep painting in the game view as well because I haven't practiced with this layout. Yeah, it's a bit too close. Don't like that. There we go. It's the Pacific Northwest, so we're going to need a bunch of ferns. I have 2 different types. We're going to put some ferns on the rocks over here. So just check that's still bypassed, but it's not bypassed on this. So paint a couple of ferns in. I think we want some sword ferns closer up. So let's put some sword ferns. There we go. That's kind of cool. We've got some grass and reeds, but I think we have large stumps, but we don't have any small. So I'm going to put in physics is still enabled. I'm going to go small, physical scatter small. Yeah, that's me overdoing it again. There we go. Let's do that. Now, I don't really like how that's fallen, but I don't have to just undo it and keep reseeding it to see what's going to happen. I can select it and say, hey, that socket there, I'm going to move it over.
Of course, physics is still enabled, so that's kind of interesting.
So actually, that one's dropped.
Just threw it under the world.
Yeah.
Bye.
Now, maybe I didn't mean to do that, but that's easy. I can just go back and I can click on physical scatter and run the rules, and they'll drop down again. And this is the one bit that John was talking about. There we go.
Yeah, determinism kind of goes out the window when you start using physics. It's close, but there's too many variables.
Yeah. So that's the last bit of physics that I'm going to do. So I'm going to turn off physics. Now I do want some reeds and grass around. So we're going to get grass reed cluster. I'm going to put this one in a new layer. And let's put a little bit down here. There we go. Maybe a couple more. And then I want to paint in quite a bit in the background just to fill up a little bit of space. There we go. Now, it wouldn't be complete without Pacific Northwest. There's going to be pine trees everywhere. We've got quite a lot of pine trees to choose from. The first one is we need some lodgepole pines that have been eaten by pine beetle. I've been doing a lot of research into stuff I never thought I needed to know about. So lots of silviculture in the Pacific Northwest. So I have some dead pines that were put together. So first one I'm going to put in a couple of dead pines. Maybe that's... So this one is ray casting on top of the rocks there, which we don't want to happen. So if I go down, I put this to bypass as well. They're going to ray cast all the way through onto the terrain underneath, which is going to look a bit better. So let's see, put a couple over here, a couple in the background. There we go, that's pretty cool. So lodgepole pines with the dripping moss, they tend to be near the water. Around there, we tend to have some beech trees, birch trees. Unfortunately, we didn't have any birch trees, but Nature Manufacture was nice enough to give us some beech trees. So I'm going to cheat, and I'm going to pretend that we have beech trees on Pacific Northwest. So just going to put in some of those. One of the really nice things we found that you just don't get with responsiveness in a normal DCC is we want some nice patchy light. And trying to guess what the light's going to do by incessantly rendering is kind of difficult. But if I put in a couple of trees, we start to see in real time. I think I want some up on here. There we go. It'll start actually shadowing in real time with the awesome God rays coming from HDRP, and we get some nice patchy. There you go. I think I'm going to go with that. I need some hemlocks, western hemlock, and some red cedar. So we've got some hemlock. These are a little bit heavier, but we definitely need some of these around the water. Cool. And then I'm going to put in some blue spruce, because the bulk of what we see that isn't munched by the pine beetle is blue spruce. So we have some spruce. And I'm just going to go to town and slam this everywhere. So you can see how fast it is just to add a ton of them. There's some reasonably complicated rule sets here with making sure that they don't cram together too closely. But I'm just going to fill up. Nope. So a little bit too much. We've just seen that's made it a bit grey and dreary. So I'm going to go back to there. And it's still looking a little bit empty. So I'm going to go back and add some bushes. So we're going to go down a layer. And I've got two different types of bushes. I've got some willow bushes. So we'll go paint enabled. Just get my camera back. There we go. So let's put, there we go, a couple of bushes, maybe a couple in here as well. And last one, just some dead, like some bramble, something like that. So some dead bushes. Put them in here. Let's put one. There we go. So could do with a little bit of finessing, could do with a bit of art direction. Since we have a little bit of time, can we have someone suggest an art direction just so I haven't canned the whole demo?
Anyone want to be an art director today?
I don't want to ask something nasty and try and screw me up.
What you got? We could slide the train around a little bit. It'd probably be weird as what happens, but sure.
Let's shift it. Let's go that. So we've just got, and that's
Of course, in this case, we're going to have to rerun the rules on everything in the entire scene, which might take a minute, but
oh, this is going to be fun. Excellent. Now, what I think I might do, just so we don't get any intersections, I'm going to leave physics off, and I'm going to rerun the rules. I think that's under here, isn't it? Update instances and scene all layers.
I will be honest that I'm not 100% sure that button actually works. So give it a try, otherwise you can do it in the inspector. So we have two ways of doing this. This is supposed to be the easy artist way to do it. Yeah, it worked, okay. But at one point it wasn't actually working. And now, again, as I said before, physics is the one thing that's not deterministic, but everything else, other than adjusting to the terrain, is going to be exactly the same result. It's going to make the exact same prefab, same scale, everything like that.
Terrain was a little bit higher, so we're now in front of the camera, but you can see everything that we put down is in exactly the same place. It's running the same rules. It's now on the new terrain. It's doing all of the art direction that I decided. It's just doing it on a different ground plane.
So just to show us something a little more, so we got that tree right in the middle there.
This one.
No, the one to the right of that, the actual tree. Yeah, let's just hide that. So we can just go to the socket and say, you know what, we don't want you there. We can just override that, tell it don't display, lock that change. And what's going to happen now is that no matter what we do to that diorama, if you change the seed, reruns the rules, it's going to know that override's there and it will never come back unless you want it to come back.
Yeah.
And lastly, let's just move the sun around.
Oh yeah, that's always fun.
Colors of, well, they've all been textured, so I mean, you have to retexture them or what. We don't have any tools to just simply recolor them. It's all done with the normal shaders and textures. So we don't have a system in place that simply says apply color variation, for example. We don't actually have something like that.
Substance integration.
Yeah, that's something we want to do is we want to integrate substance for that kind of stuff. The future. So unfortunately, nothing's ever done. It would be great if it was done, but it's not. So we have Diorama 2.0 on the horizon and a few things in mind. The first is expanding the rule set. We have a very basic rule set now that just does what we need, but the whole system is designed, the rule system is designed so we can easily expand as new functionality is required, as new show requirements come around. So that'll be expanded in the future. We have a couple of specific things in mind. The first is making rules more contextually aware of what's around them. Let's say you have a diorama that you place by a river versus a diorama you place by, let's say, a city or a road. The sockets can be more aware of what's around them and then choose different results based on that. The other one that we're just kind of has some ideas to look at is Houdini integration, specifically in the form of using HDAs inside of Unity. Theoretically, we could have, like, say, a cook HDA rule inside of a diorama that would pass information from the scene to Houdini, cook out an HDA, bring the result back, and then display it in the diorama. It might be a little slow, but Houdini has great procedural modeling tool set, and it'd be nice to be able to leverage that. The other is a bit of a UI overhaul. When this whole project started, remember we mentioned node-based systems. When we went into Unity, well, there was no more node-based systems, so we built more of just a traditional inspector, and it worked. But recently we've started having a little bit of hacks here and there, and one of those big hacks is what we call the attribute system, which is what made the lookat and clustering rules, for example, work. It's when a socket needs to have information passed to it from another socket, how do you do that? Right now, you kind of like save the output of a result of one rule into the attribute system and then get that result back, and it's a bit hacky. Recently, Unity showed off their VFX graph, which I think looks absolutely amazing, and it's this hybrid node stack-based UI, which I think would be great for Diorama as well, and it would give the artists a lot more flexibility. So MPC's Genesis platform, you probably have heard of that by now. It started as a virtual production platform, and it's expanding now beyond that. It's built on Unity, currently powers MPC's virtual production, but as I said, it's being expanded beyond that. Diorama is now integrated into Genesis platform, which makes Diorama seamlessly available to our artists in multiple areas of the pipeline, including previs, virtual production, and actual VFX production, so we can provide seamless work from one end to the other with the same tool set. Now, looking even further to the future, we have a couple of things in mind and how Unity can help us with those. So the first is just punching those visuals as much as we possibly can. Besides it just being fun to do, there's specific reasons for that. One is we can get better client feedback if we give them better visuals. We're quickly getting to the point now where gray shaded Maya playblasts just don't make them happy. They're seeing better than that in previs, so we need to up that. And the more we can give them, the better they can give feedback to us. It also internally allows us to make more informed decisions. And I know for a couple of us, our pet project is to see final pixels from Unity on the big screen. We came really close on one project, but didn't quite make it. Actually, I think technically we did, but it's kind of a technical thing. The other is building bigger worlds. Right now, with Unity's classic SIGGRAPH, we can get roughly 40 to 50,000 objects in the scene before it becomes not a polygon issue, but more of a scene graph issue. We want to target millions of instances of things in the world, and one of the things that's going to help us get there is the Unity's DOTS, or data-oriented tech stack, and the entity component system. That will also allow us to do things such as streaming in assets as they're needed in the scene, and possibly reducing our upfront time and getting artists up and running so they can be bringing in assets from the pipeline in the background while they're working on what they already have. So yeah, thank you very much for coming out today. Our time was eaten into, so we're almost out of time. I probably could take one quick question, I guess, if anyone has a burning issue. Otherwise, you can come talk to us afterwards.
I was wondering, as an artist use Diorama, are you guys automating like a Unity-centric asset that's coming from like the asset? Are those things happening currently? Is there artists building the content?
So the question is basically about how we interact with the pipeline, right? And to really quickly summarize that, there's no live connection going on, but what we do is we import the MPC pipeline assets into Unity in such a way that we know where it came from, and then we lay it out, and then when we output it from Unity is essentially just a list of saying it came from here in the pipeline and here it is in the world, and so then the rest of the pipeline just uses the original assets that were there. One really cool, powerful advantage of that, though, is you could actually use different assets in Unity as long as they like physically line up, and they'll just reference back to the original ones as well. It's just a simple component on there. So, excellent. Well, thanks, everyone.
We'll be outside if anyone wants to come and talk to us, but we want to keep everything moving on. Thank you very much.